Well, everybody, I decided that I'm going to make the missing bracket so I can put this Craftsman sander together and sell it. I ended up doing the trade for the grinder for one of my compressors and a small sander I had, but now I still have this sander sitting here in my way, and I just know that, well, as you guys probably already realize, I have trouble finishing projects. One of my viewers just mentioned that I guess in one of the flea market finds videos just recently, I was talking about all that metal I got for when I want to make projects. And he made a comment about I talk a lot about making projects, but he doesn't see the projects. So, all right, Larry, here we go. This is a piece of metal I just cut from that haul. We're going to make that cast bracket out of solid steel, so it's actually going to be, I think, an improvement over what was there. So my first problem is I've got to locate the two holes that actually mount the bracket to the base. So what actually holds the bracket onto the base here are two bolts that actually go through that metal piece I was just showing you on the bench, that sheet metal piece, and then they pass through the bracket and thread into these two holes right here. So this, I want this to sit on this shelf right here, and then I want the holes to be here. Now, so how do I locate those holes? Well, they're offset. You can see this one's higher than this one. So the easy way to do it, if I had them, would be to use these things. I don't know if these are called transfer buttons, or for lack of a better term, but they're little threaded inserts that have a little sharp point on them. And what you do, if that's going to focus on that or not. And what you do is you find the one that's for the corresponding hole. I actually have a pair of these large ones. These are the only ones I have. And these were just miscellaneous that I found in something. So what you do is you find the proper pair, you thread them into the holes, you hold your piece over them, you give it a whack with a hammer, and it makes a little indentation, two little center points of right where you want to drill your holes. So as I just explained, I don't have two of these of the right size. So these come in a kit normally with a whole bunch of different sizes and multiples of the same size in case you have multiple holes you're trying to transfer. So I was thinking, well, I could use this plate as a template or a guide, so to speak, and then use transfer punches. Now, I've got a transfer punch here. Basically, this is going to fit right in this hole. And, oh, that's the other thing, too. This is actually a pretty decent fit in this hole, and it's sloppy as heck in this hole. So what I found out is they didn't even bother having two of the same size holes in this sheet metal piece. This one fits almost perfect in this one, and it won't fit through the hole in this one. So I'm going to have to use one size transfer punch for there and one size for here. No big deal. I'll survive. Not going to keep me up at night. But my problem is, as you can see, this has got an angle on it right here. This line on the bottom here is the line that would be normally parallel with that shelf that this is going to sit on. Now you notice I said parallel and not sitting on it. The reason why is I can't just line this line up with this edge here like I wanted to do and go, okay, there we go, that's a good spot. Clamp it here, bang, bang, and I'm done. Nope, not going to work. Why? Well, I'll show you why. So the problem is, when I put this on here, if I just sit it on here like that, the holes don't line up. This is actually too low. When this is bolted in position, it actually sits up here like this. There's a space there. And I don't want a space between the bottom of my bracket and this shelf. I want that bracket to sit on this shelf, because the only thing that holds this bracket to the base here are these two little bolts. So I think a lot of the strength of this whole assembly is actually derived by the fact that it kind of sits on this shelf. My thought was, well, no problem. I can find out what the size of that gap is right there. Could even use gauge blocks if I wanted to get really technical, but the reality is if I just take this parallel and I stick this on here like that, and I look at it, at first glance I thought, oh, perfect. But then I realized that for some reason, I just hit the camera with my head, but for some reason right now that one's lined up, this one's a little low. This needs to be tilted just up a little bit. Not much at all, just a very little bit. So what that told me was that unfortunately this is not, the gap between the bottom of this plate and this area right here is not parallel. So in other words, this line right here on the bottom of this and this line right here are not going to be parallel. Does that make sense? All right. But it's such a slight amount that I think what I'm going to do is I think I'm going to still use this spacing right here. And then I think my through holes in the bracket, I'm going to leave them just a tiny bit large enough so that hopefully I'll be able to get this to actually sit down flat on this thing. It's not the ideal scenario, but the only alternative I could think of is if I try and get really fancy and maybe put some bolts in these holes and then try and take measurements to find the exact height distance from this flat surface right here up to the center hole of this bolt hole and also to this bolt hole. But that could get tricky too, because it's quite possible that this flat area right here is actually kind of going downhill a little bit. I don't know. So I thought about it, and I thought, you know, if I really want to get precise positioning of these holes in respect to this area right here, what I could do is I could take this whole base right here and put it on my cast iron surface plate, and then use a height gauge and put a precision pin in one of the bolt holes like this and get the height off the top of the pin to the plate, subtract half of the diameter of the pin, and that would give me the center line height of this bolt hole above this area right here. Then I could measure this from this plane right here to the surface plate to get the dimension from here to here, subtract that out of that, and that would give me the dimension from here to the center line here.
Then, since I could arbitrarily pick any spot from the edge of my new bracket to start hypotenuse of a right triangle here, if you see it.
But what is apparent to me is that I think I'm just overthinking this whole thing. And I'd be willing to bet that if I had the original bracket in front of me and I were to look at the holes on the original bracket, I'd be willing to bet that they're not precision holes, that they're actually a little larger than the diameter of the screws and would allow for a little bit of fudge factor. So I think what I'm going to do is I'm going to just ham and egg this thing, I guess. All right, so here's what I did. I took my pin, one that fits in that hole really well, and I stuck it in there, and I took this little depth gauge, and I basically held this on this top surface of the pin here, okay, and brought the blade down so it's just touching that top surface that I want the bottom of my bracket to rest on, okay. And I tried to keep this as horizontal, or I tried to keep this line right here as parallel to that surface as possible, because obviously if I tilt it over there's going to be some error, but error but anyways, if I tilt it over, as I tilt it, it's going to change that obviously, but I'm hoping that just by eyeballing it, the amount of error would be negligible in my final calculation here. So I took this measurement right here. I don't know what this is yet. Then I took my pin, I came out and I measured my pin, and my pin, not this dimension that goes in the hole, but the dimension that I actually used as the surface for the depth gauge, is actually 312 thousandths. So 312 thousandths. So half of that is going to be 156. So let me just write that down before I forget. 0.156. Okay, so now if I subtract 0.156 out of whatever this dimension is, that should give me the dimension from the center line of this hole to that point, to that base. Go just a little past it. Oh, you know what? See, I'm not bearing on the right surface there. That must be what makes one of the things that makes these right-hand calipers. I'm a lefty, Those of you didn't know. Some of you right now are going, "Oh, he's left-handed." That explains a lot. All right. Wow, that's almost dead on. Oddly enough. 700 thousandths. Matter of fact, if I take that thousandth away and I subtract 155 from that point right there, if I subtract 155 because I just took the thousandth away, so now I got my first dimension. I wrote it down here. Now I could reset my caliper and then find the other ones, but as long as I get the calipers set, I'm just going to use the calipers to describe the line. So first thing I'm going to do is I'm going to see and make sure that this is square. Now if I wanted it dead on square, then I really should stick it in the mill, face one edge, set it up in the vise properly, and face the second edge so I have two reference edges to go off of. But in actuality, this is square enough for my purposes for this project. I could clean this up. I'm going to leave this dirt on here because it's the poor man's Dykem blue. The next dimension I want to find is I want to find a dimension from this edge to the center line of this hole right here. And I had said that was going to be an arbitrary, dimension. I just wanted to make sure I had enough meat here so when I drill the hole. But in reality, I forgot about the fact that the way this original bracket was made was it was narrower here, and then it gets larger over here. So unless I have a clearance issue later, I'm not going to bother taking out this meat right here. So what I want is I want to know that this large diameter right here, which the center of this large diameter is the center line of the shaft. I want to know that this large diameter is more or less centered left to right on this whole width right here. So what I can, because I can always later on, if I have to, I can always mill off something on one of the edges if I want to move the bracket, if I want to remove any material that might be impinging on something I haven't thought about yet or realized yet. Okay, so what I noticed is that when I put this line right here parallel to the bottom, that this slot that they have right here is pretty much vertical to that horizontal. perpendicular. Okay, so I can eyeball where that's going to be. So what I can do is just take the width of this whole piece, divide it in two, give myself a line here. Breakfast is ready. It's now Sunday morning, in case I didn't mention it. All right, it's been a few days since I've been down here and had time to mess with this project, so I don't remember exactly where we left off, but where I left off, we being me and the mouse in my pocket. Anyways, I had located one of these holes in one axis, and then I decided before I locate the other hole that I wanted to locate this hole here for the spindle. So I decided that since this slot here is on the center line of this circle, that what I'm going to do is I'm going to put that slot right on the center or the halfway point. So
I don't remember what I measured, or if I did get around to measuring this, but I'm basically going to take the overall dimension of this, roughly.
Make a quick mark there and just, yeah, that's where I want to be. So I'm going to make a little line there, and I'm just going to scribe. Oops. Part of my problem is the tripod is right in my way. So now to locate this hole, I'm going to basically eyeball this. I'm going to hold this plate so that that line that I scribed is in the middle of that slot, and at the same time I'm going to have that line that I have scribed over here in the midpoint of that hole. And once I get that right where I want it, then I'm going to stick the transfer punch in there and smack it.